2 on the back? There was only 2 on the back, wasn't there? Oh, 3. Oh, number 2 on, ooh. Okay, yeah. I think 2 was hard because of the equation that was there. All right, so number 1, t cubed minus 12t squared plus 36t, where t is greater than or equal to 0. And of course, that means time's got to be bigger than 0. Can't have negative time, so that's why that domain restriction is set there. First thing, ask me to find the velocity at time t, so that is nothing more than the derivative of position. What is the velocity after 3 seconds? So then I just plug in 3 to the velocity equation. So that would be 927 minus 72 plus 36. That would be negative 36. 27, what is that? Negative 9 meters per second. So what y'all got? I'm sorry I didn't have answers for these. I hadn't worked them yet. When is the particle at rest? So what happens when the particle is at rest? What am I looking for? Velocity of 0. So I want to know when does, so let's see, this is A, this is B. When does velocity equal 0? That's my question. So I've got the velocity equation, so I'll just set it equal to 0. It's a nice little quadratic here. I may even be able to factor it. Now I can take a 3 out. Anything multiply to 12 and add to negative 8? Negative 6, negative 2. There you go. 3, t minus 2, t minus 6. I got kids in honors pre-cal that still can't factor, and yesterday we had to factor pre-cal. All right, t equals 2, t equals 6. There are the 2 times. Does it make sense to you that I'm hitting, oh, well, never mind. I'm at rest twice, right? I don't know if I'm changing direction or if I'm just stopping to rest, but either way, I am resting at that point. Say that again. What 3? Oh, no, not whenever you're solving, because if it had a variable there, yes. So if you took out a 3t, you would say t also equals 0. But because there's no variable hooked to this, you could really just, when you're solving, divide both sides by 3. So then really, t minus 2, t minus 6 equals 0. So it won't impact your answer. When is the particle moving forward? So now I have to do my little sign chart, and I have to think about this way. Okay, well, here's 0. I can't be less than 0, so that's the smallest I'm going to start with, and I'm going to include 2 and 6. Velocity sign being on the bottom, which is just the derivative of position, and up top would be my position. So between 0 and 2 is my velocity equation positive or negative? So I'm looking at my velocity equation, positive or negative. So I put in a 1. 3 minus 24 plus 36. Is that positive or negative? Negative 21 plus 36 is positive. How about between 2 and 6? So maybe 3. Negative. And then how about bigger than 6? I think it's going to be positive. So what does this tell me? When is the particle moving forward? The particle starts out moving forward until 2 seconds, and then moves backwards, and then at time 6 seconds, he starts moving forward again. Forward, right, up, all the same thing. Moving in a positive direction. Does that make sense? Are y'all okay? So the answer would be, so the question asked me, when is the particle moving forward? I am moving forward from time 0 to 2 seconds and from time 6 seconds on, or forever or continuing. Yes. Yes. Just make sure you still put your units on here as seconds, and that you still say the particle is moving forward on the interval, and then you say this so that they know. E, find the displacement of the particle after the first 8 seconds. So displacement is final minus starting, right? So I need displacement. Right? Change in position. So to find that, I need the position at 0, and then I need the position at 8. Position is t cubed minus 12t squared plus 36t. So if I put a 0 in there, I get 0. For the 8, 8 cubed minus 12 times 8 squared plus 36 times 8. I don't know what you get there. Anybody? That original equation is just there. Anybody? I don't have my calculator on me. 8 cubed minus 12 times 8 squared plus 36 times 8. Oh, thank you. 32. That's okay. 32 meters. So what's my displacement? My change in S is 32. Is that how far he actually traveled over the 8 seconds? No, because he went backwards and forwards, right? He went backwards during this interval. So it's not the total distance he traveled, but it is the displacement. It's the difference in where he started. So we're going to skip F for the time being. Diagram to illustrate the motion of the particle. That's what we did here. Or you could say, well, he starts out at 0, he moves this way, and then he moves this way, and then he moves back this way. We will get more in depth with that a little bit later on. Find the acceleration at time t and after 3 seconds. Oh, yes, or the sign chart you did initially. To help you describe the motion, because you'll have to write it in words, and you'll have to say exactly what happened, so it helps you see what's going on. Because we're going to, when we get to integrals, we'll do total distance traveled. It's a more efficient way of doing it instead of confusing you more with going in. And the only way you could do it now is if you did displacement from 0 to 2, and then displacement from 2 to 6, and then displacement from 6 to 8, and then added all those together. H, find acceleration. So acceleration, of course, is the derivative of velocity, which is the second derivative of position. So we had, let me just write it down because I don't have it, 3t squared minus 24t plus 36. That's velocity. So I need the derivative of that, which would be 6t minus 24. Then it said find the acceleration after 3 seconds. So plug in a 3, you get 6 times 3 minus 24, which is 18 minus 24, which is what? Meters per second. Graph the position, velocity, and acceleration functions between 0 and 8. So the first one is a cubic, and I don't really care that you can do this exactly. You can use a calculator to do this. In fact, let's do that because it's a little easier on your calculator. still recording. I don't even know what's going on with this school computer. Oh, where's my... So I'm just going to grab them all in the same window here. It's dark. Huh? What's wrong? Probably stomping down the hallway. X cubed minus 12x squared plus 36x. Then I'm going to do 3x squared minus 24x plus 36, and then I'm going to do 6x minus 24. 0 to 8. I don't think that's going to pick everything up, but we'll see. There's my cubic. That's my position function. There's... I have 2 cubics. Was it a problem? Oh, it looks like... Okay, let me go. There we go. So there they all are graphed. I can take it up even. Yours doesn't look like that, or does? Your window might just be set different. You don't have to. I just wanted to, but you don't have to. So now the question is, when is the particle speeding up? When is it slowing down? So I could use several different things, or a couple different things. I could look back at my original sign chart here, and then I only really have to look at the acceleration on my graph, because I want to know when the signs are the same, right? This is a little bit easier for me to see, so I'm going to do it. I'll do it both ways. So I'll do it first. 2, 6, and it tells me to stop at 8, right? Is that what it said? All right, so positive, negative, positive. This is velocity. This is position. So here's my chart. And if you go back to your calculator and I only look at acceleration, looks like it's crossing at 4, but let's check it. Four. So it's negative then positive, and 4 is where it switches. Does everybody see that? So 4, here's my same number line, right, to 8. This time it's divided at 4, which is exactly between here. And it goes negative, positive. So now if I kind of divide this up, I may be confusing you more dividing it the way that I am. So negative, negative, this is still negative. Positive and positive. And then negative and negative and positive and positive. So where are the signs the same? Because that's where it's speeding up. All right, not there. So it told me just to go until 8, I think. Yeah, it says from 0 to 8. So the green circled is speeding up. because they have the same sign. It doesn't matter if they're both negative or they're both positive. It just matters. So speeding up would be from 2 to 4 and from 6 to 8 seconds. Does that make sense? And then slowing down this is the hardest part of it. From 0 to 2 and then from 4 to 6. Okay. Is that what y'all got? All right, is that cleared up about number 1? All right, you asked about number 2. I'm assuming, was it with the derivatives that was hard or all of it? T over 1 plus t squared. So velocity here, because x of t is my position, velocity is going to be the derivative of this. I would split this into 2 fractions. Nope, you can't split this in. Okay, we don't have any choice but to do quotient, right? Derivative of the top is 1 times the bottom minus the top times derivative of the bottom all over the bottom squared. Clean it up just a little bit and let's hope it looks a little better. 1 plus t squared minus 2t squared over 1 plus 2t squared plus t to the 4th. I don't know if I needed to do that or not. But I might just leave that in factored form that way. Either way is fine. That is a difference of 2 squares up top. I may need to. Which 2t? T squared minus 2t squared is negative 1t squared. It may help me because I know I'm going to have to find where it equals 0 at some point, right? So it may help me to write it as 1 minus t, 1 plus t over whenever I solve, but you don't have to. All right, so there's the derivative. When is the particle moving to the right? When is it moving to the left? So first thing I need to do is find where it equals 0, right? I'm also going to need to account for any discontinuities because it could change direction there. So whenever I do this, I want to set up my discontinuities, which would be my vertical asymptotes, as well as, if this has any, and it may not have any, as well as holes or places where it equals 0, okay? Because those are all places where the derivative can fail to exist and then something else funky can happen. So let's see. Where does it equal 0 first? So I'm looking at this. So for a fraction to equal 0, what has to happen? The top has to be 0. If the bottom's 0, what does that mean? Undefined, right? That doesn't make it 0. To make it 0, the top has to be 0. So all I'm going to do is take the top of this and set equal to 0. So I get 1 and negative 1. This doesn't make any sense, right? Why does t equals negative 1 not make any sense? Time's not going to be negative. So that's the only one I'm really looking at, yes? Does that make sense to you? This says when, I'm looking for when is it moving left or right? The bottom is not going to make it equal 0. There's nothing you could plug into the bottom that would ever make the fraction equal 0. The top, however, could be 0, and that would make the value 0. The top going to 0 would create an asymptote. In this case, there's nothing I could plug into the bottom that would make that be 0, right? And if you think about it, what could you plug in for t that would cause that to be 0? Well, the only thing that would make it 0 is if I could make that be -1. And there's no way to make that -1 because I'm squaring it. It would never be negative. So the bottom is a moot point as far as asymptotes go anyway. You need to really check for an asymptote to see if it's got an asymptote there. But we'll hit on that in later chapters where we start testing those points of discontinuity. But right now, worry about where it equals 0. We will get there, so I don't want to tell you, no, you don't ever have to look, because we will get to that point right now. All right, so time 0, time 1, x of t, which is just my position, and then velocity. So what is the sign? Now look at this fraction. The bottom of this fraction on your velocity is always going to be positive no matter what. Do you see that? As I'm trying to figure out what the sign of, I'm trying to use little tricks that are going to help me evaluate things without going through the whole thing. I don't want to plug in a value every single time if I don't have to, because that's a lot of work. That's a pretty involved. But if I look, this is always positive, right? Because you're squaring it. If you square anything, it's always going to be positive. So really, I need to think about what the sign of the top is, because the sign of the top is going to impact the sign of the whole thing. So I'm really only looking at 1 minus t squared. Do you understand why? Does that make sense? How I just eliminated the bottom. So if I put in a fraction between 0 and 1, so maybe a half, do I get positive or negative? From 0 to 1. It's positive. If I put a half in there, that's a fourth. 1 minus a quarter is still positive. How about if I put a bigger number? Negative. The bigger it gets, I'm squaring it and I'm subtracting that from 1, so it's going to go down. So where is my particle moving right and left? From 0 to 1, it's moving right, and from 1 until whatever, the end of time, I guess, it's moving left. Does that make sense? Y'all see how I'm reasoning through that? I'm trying to talk you through my thought process, but that could be a little scary sometimes. My thoughts are all over the place. Okay, find the displacement during the first 4 seconds. So that's a little bit easier. I need the starting, and I need the, and I think they used x on this one instead of s. One to infinity, right? Okay, at time 0, I'm 0 over 1 plus 0 squared, which is simply 0. So I still start at 0. I start at that initial, which is good. And then at 4, at time t equals 4, I'm 4 over 1 plus 4 squared. So I'm 4 over 17 meters, or whatever it is, whatever these units are this time. Meters. I did not go very far. 4/17 of a meter. So my displacement, if I good? Which one am I? Skip D. So E, the acceleration at time. So we got to go back to this velocity equation, which was kind of nasty. I'm going to pick the easiest one, I think, that is going to be for me in order to find the derivative, and I think that will be this one. Yes. All right, so this velocity, so here we go with this derivative. Great day. Derivative of the top. No. No, 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 no. Okay. Sure. Okay. Derivative of the top times the bottom minus the bottom. Whoa. Oh, just kidding. Minus the top. What? T to the fourth plus 1. You can't distribute. You'd have to FOIL it out. Okay, so yeah, derivative of the top is negative 2t times the bottom. So this is top derivative times bottom minus the top times derivative of the bottom. Now, we haven't learned chain rule yet, so you're going to have to, on this one, multiply this out to find the derivative. Okay, so 1 plus 2t squared plus t to the 4. So the derivative is, yes, 4t plus 4t cubed. All over the bottom squared. But listen, I can combine those and just make that to the 4. But I can't distribute that inside. I would have to multiply it out 4 times. But I'm not going to mess with it. I'm going to leave it just like that. I might simplify the top a little bit, but depending on what they're asking me, whenever it gets to this type of stuff, I would probably stop right here before I make a mistake in my algebra, because gross. Well, if this is a calculator problem, this one would most definitely be a calculator problem with these equations this way. Absolutely, you can graph it like that. You can put it in your calculator like that. You just got to watch parentheses when you input it. But okay, so you can definitely, so maybe clean it up just a little bit. Maybe negative 2t times 1 plus t squared minus, and maybe you multiply this out maybe. I don't know. There's not a whole lot in here I see that I would do with it before trying. I'm paranoid about making a mistake. So I want to stop whenever I can. I would stop there. With all these exponents and stuff. All right, so that's my acceleration. When is it 0? So I would need to say, when is it 0? But remember, this is a fraction, right? So the only time this is going to be 0 is when the top is 0. So don't worry about that bottom right now. So when is negative 2t times 1 plus t squared minus 1 minus t squared 4t plus 4t cubed, when is that equal to 0? And that I would take out my calculator and I would look at it. And it just says between 0 and 4, right? It doesn't say that, but that's what we're looking at. Yeah. So I would most definitely take out my calculator. Let me type it and then I'll show you. I don't, is it? Yeah. Let's look at it. 1 minus x squared 4x I only see it crossing one time on mine. Is that what y'all got? Whatever it was on before, I didn't change it. I might change this instead of 8 to 4. Up and down, it really doesn't matter because I'm just looking for, remember I set it equal to 0, so I'm just looking for where it crosses the x-axis. So I'm going to calculate the 0. So where is acceleration 0? Acceleration is 0 at approximately 1.732 seconds. No, that would, plugging 0 in for t would say what was the acceleration at the starting time. This was a nasty one. When is it speeding up or slowing down? I'll save you the graphing since you can use the calculator on that. Speeding up or slowing down, I know where it's 0 now. Did I do velocity equals 0? Yeah. So I'm going to come back to this chart. I'm only going to 4, and this was what, 1.73? And it was negative and then positive. So where are the signs the same? It looks like, yeah. Yes. Well, as long as they're in the right place, no. Oh, wait. Why did you put 4? I have an older one. So if this is 1.73, right, it looks like, so this is still negative here, and this is negative, positive, but I'm negative here. So both of them are negative. It looks like this little window right here. So speeding up from 1 to 1.73, that's a really bad habit that I'm doing. I need to go out 3 decimal places. I don't want to lose my answer point. 732. Gotta name the intervals. You'll see when we start grading those FRQs, they are so specific in what you get points for and what you don't. So you'd rather have too much than not enough. Are you feeling any better about particle motion? This was a hard one. Right and left, positive, negative. Up is right, down is negative. Huh? Do you need me to do number 3? Okay, let's see. I'll run through this one a little bit quicker. This one's a lot easier. There's your position, so your velocity is the derivative. Acceleration is, of course, the derivative of that. When is it moving upwards, and when is it moving downwards? So I would need to know when velocity is 0. So 3t squared equals Well, t squared is 4. Plus or minus 2, but the negative really doesn't make sense because I can't have negative time. So from 0 to 2, I am looking at velocity to tell me what position is doing. From 0 to 2, if I plug 1 into the velocity equation, 3 minus 12 is definitely a negative number. And then if I plug in 3, I get 27 minus 12, which is a positive number. So I'm moving down from 0 to 2, and I'm moving up from 2 to whatever. I think you're going to 3 on this. Displacement is just initial minus beginning. So the change in S, I need to do the initial and the ending. Initial is just going to be 3 if I plug in 0. If I plug in 3, 27 minus 36 plus 3. Negative 9 plus 3 is negative 6 meters. So what's the displacement here? Right, negative 9. Because it's, yeah, you're subtracting. If you think about it on a number line, if this is 0 and this is 3 and this is negative 6, how much space is between? Distance traveled, nah. Graphing, you can use your calculator. Speeding up, slowing down. So again, where is acceleration? 0. Well, when does 6t equal 0? 0. So if you think about it graphically, that makes sense because it's got a y-intercept of 0. It goes up 6 over 1. So there's my acceleration. Acceleration is always what? Positive. So if I do this, 0 to 3, acceleration is always positive. So where is it speeding up? That's exactly right. This one's a little bit easier to see. Maybe we should have started with this one. So speeding up and slowing down.